In recent discussions, there's been a provocative claim circulating that Retrieval-Augmented Generation, or RAG, is dead, supposedly killed off by agents and buried by context windows. However, the truth is much more complex and intriguing. While some argue that new technologies are overshadowing RAG, it's crucial to explore the nuances and ongoing debates within the tech community. Let's dive deeper into this fascinating topic and uncover the real story behind the headlines. Welcome to today's discussion on the viral claim about context windows in AI models. The article suggests that with the expansion of context windows, like Claude's 200K tokens and Gemini's 2M tokens, the need for complex retrieval methods like RAG might be diminishing. Furthermore, with agents capable of dynamically searching entire codebases, the question arises, why rely on intricate vector retrieval pipelines when you can directly access or search the data live? Here, we address a key comment that challenges the use of grep in enterprise scenarios. While grep excels with thousands of files in a codebase, enterprise knowledge bases involve millions of documents. Codebases benefit from precise token matching and structured formats that fit large context windows. In contrast, enterprise environments require semantic understanding across messy, varied formats, leading to astronomical inference costs at scale. This highlights the distinct challenges of enterprise-level data management. As we explore retrieval systems, the real question isn't about selecting a specific RAG model, but rather understanding the level of intelligence your system requires. The 8 architectures we've examined aren't just options on a menu. They represent an evolutionary journey, each enhancing the system's capabilities. Instead of focusing on a single choice, it's crucial to grasp the overall direction and potential of these advancements.
Welcome to Chapter 1, The Foundation, where we explore naive RAG. This process begins by chunking documents into manageable segments. These segments are then vectorized and stored in a vector database. Through a similarity search, we retrieve chunks that closely match the query. The language model then uses these to generate an answer. It's a simple and fast approach, but remember, if low-quality data is retrieved, the output will also be compromised. Welcome to Evolution 1, Quality Control. Our focus here is on enhancing corrective RAG by integrating a quality gate. Previously, naive RAG would pass all retrieved content to the language model, including irrelevant data, which could compromise the answer. Our solution evaluates each piece of retrieved information. Relevant content is used, irrelevant is discarded, ambiguous is refined and re-retrieved. And if information is insufficient, external sources are automatically searched.
Welcome to Evolution 1, Quality Control, featuring Self-RAG, the self-aware system. This marks a major philosophical shift in AI. Now, instead of blindly executing tasks, the model makes critical decisions. Should it retrieve information? Is retrieval necessary or relevant? Does the document address the question? Is the answer supported and grounded in evidence? Ultimately, is the response useful and does it truly help the user? This elevates AI's role in quality control.
Welcome to Evolution 2, the multi-perspective approach, introducing multi-head RAG, which brings multiple viewpoints to the table for a single question. Often, questions require insights from various angles, like financial, legal, reputational, and operational perspectives. Multi-head RAG retrieves relevant information simultaneously from different sources, ensuring a comprehensive understanding by merging these insights. This approach ensures no critical angle is overlooked, providing a well-rounded answer to complex queries.
Welcome to Evolution 3. Structure. In this section, we'll explore Graph RAG, an innovative approach to understanding relationships. Unlike traditional RAG, which focuses on finding similar text blocks, Graph RAG delves deeper, analyzing entity relationships within a knowledge graph. This method offers real-world precision. For example, when asked, "Who leads ABC company's supply chain?" Graph RAG doesn't just match keywords, it traverses relationships, providing precise, connected answers. Welcome to Evolution 4, True Intelligence. Here, we introduce Agentic RAG, the intelligent agent. Unlike traditional systems, this agent goes beyond mere retrieval. It actively plans, chooses, and iterates until achieving satisfaction. It starts by receiving a problem, then evaluates the situation. It retrieves and reasons, selects the appropriate tools, and decomposes complex tasks. This level of intelligence marks the pinnacle of evolutionary development in artificial intelligence systems.
Welcome to Evolution 4, True Intelligence. This breakthrough features adaptive RAG, which tailors its strategy based on question complexity, offering direct answers for simple queries, iterative retrieval for multi-step ones, and creative solutions for open-ended questions. Backed by Salesforce research, the SF RAG model sets industry standards with high-quality embedding, optimized result reordering, context compression, and robust quality verification, ensuring that our AI solutions are both powerful and reliable. Welcome to the evolutionary map of the 8 architectures. Each step adds new capabilities, building upon the previous one. We begin with naive RAG, a basic pipeline that processes and answers. Corrective RAG introduces quality control, filtering errors. Self-RAG gains self-awareness, evaluating its own performance. Multi-head RAG explores multiple perspectives simultaneously. Graph RAG understands structured relationships. Finally, Agentic RAG emerges as a fully autonomous system, capable of planning, iterating, and making decisions independently.
Today, let's take a closer look at the popular article claiming a RAG is dead. While it presents a strong argument, it overlooks 3 crucial aspects of the real-world challenges we face. First, it doesn't fully address the evolving complexity of modern systems. Second, it underestimates the adaptability of RAG frameworks. Lastly, it fails to consider the integration benefits that RAG still offers. These blind spots are critical for a balanced perspective. Let's talk about the first blind spot: cost and scale. When dealing with large language models, the math simply doesn't add up. Imagine 200,000 tokens equating to 150,000 Chinese characters. Now think of enterprise knowledge bases with millions of documents. The cost to process all that data would be enormous. Plus, research shows these models struggle with long contexts, often missing crucial information in the middle, proving that more context isn't always better. Let's explore blind spot 2, semantic versus precise matching. Exact matching, like grep, finds documents with specific phrases, such as supply chain risk, but misses related concepts like supplier dependencies. Semantic retrieval understands broader meanings, capturing conceptually linked ideas, but may overlook exact language. The best practice is hybrid retrieval, merging both methods for comprehensive coverage. This approach balances concept discovery with precision, making it ideal for mainstream applications. Title: Blind Spot 3, Concept Confusion. There's a common misconception that agentic search replaces RAG, but that's not quite right. Agentic RAG is actually a type of RAG, not a substitute. As someone pointed out on Hacker News, RAG isn't an architecture. It's a principle centered around using retrieval to boost generation. The role of agents is not to eliminate RAG, but to enhance it by giving it more intelligence.
When choosing a system, ask yourself 4 key questions. First, how large is your knowledge base? Simpler architectures work for thousands of documents, but millions require more advanced systems like Graph or Agentic. Second, consider the complexity of your questions. Single-hop lookups differ from multi-step reasoning. Third, determine your error tolerance. Systems in customer-facing or regulated industries need robust verification. Lastly, assess your budget. as advanced systems have significant costs. Start lean and scale wisely.
Today we'll discuss 3 practical rules for improving your AI deployment process. First, start simple with naive RAG and add complexity gradually. Avoid the trap of deploying everything at once, like graph and multi-head, which often leads to delays. Second, create your own evaluation suite with real business questions to guide improvements effectively. Lastly, optimize retrieval before generation, as the quality of retrieved documents fundamentally impacts your output. Focus on getting this foundation right. RAG isn't dead, it's evolving. We're moving from a simple technical trick to a complex system engineering discipline. Large context windows are just one tool among many, not a replacement for the entire field. Think of these 8 architectures as an evolutionary map rather than a menu. Each adds intelligence in a specific way. Understand the direction, choose your starting point, and upgrade along the path. It's not about choosing RAG or not, it's about determining the level of intelligence your retrieval needs.
Welcome to our discussion on your RAG journey. We'd love to hear about the architectures you've deployed in production. How has complexity been a friend or foe in your projects? Share your insights in the comments. What architecture are you using and bend at what scale? And finally, what has surprised you the most along the way? Join the conversation and help us all learn from your experiences.